Hello everyone, Assalamualaikum warahmatullahi wabarakatuh. Today we will discuss how electricity can be carried to the consumers via electric power systems. So, what is a power system? And what are the main parts and functionalities of a power system? Let us have a look at a representation of a traditional power system. A traditional power system consists of three main components: the generation, the transmission, and the distribution system. We call it traditional because the generation of electricity is centralized, meaning that only a few large power plants are involved. The generation system comprises the power plants that supplies power to the system, also called generation stations or generation units. Some examples of traditional power plants are thermal, hydro, and nuclear power plants. The transmission system is made up of transmission lines that transport the power from generation system to the distribution system. And typical voltage levels for the transmission system range from 10 kilovolts to 1100 kilovolts. In Indonesia, the typical voltage are 70 kilovolt, 150 kilovolt, and 500 kilovolt. The distribution system is the network that feeds power to the load. The load represents the power consumptions of a system. It contains households, hospitals, commercial buildings, and small to medium-sized industries, among others. And the typical voltage levels for the distribution system go from 120 volts up to 10 kilovolts. However, in Indonesia, the distribution level is 220 volts up to 20 kilovolt. The voltage level of the transmission system are higher than those of the distribution system. You might wonder, how does a voltage level change from one system to the other? In power system, this is done mainly by means of transformer. A transformer uses electromagnetic induction to transfer electrical energy between two or more circuits. A typical transformer consists of two windings, and depending on the ratio between the primary and secondary winding, the voltage will be increased or decreased. Transformers are generally placed at substations. A substation contains many elements that are important for keeping the system operating between the admissible boundaries. Some of these elements are transformer, capacitor banks, switches, circuit breakers, monitoring equipment, protection system, etc. In short, an electrical power system is a network used to supply, transport, and distribute electric power to the load. Let us have a closer look at the diagram. Notice the direction of the power denoted by the arrows. As you can see, there is a unidirectional power flow, which means that generation occurs only at the generation side of the power system, and consumption only at the distribution side. This is one important characteristic of traditional power system, but there are some other characteristics that are worth mentioning. Most power plants are controllable, and large voltage is increased or decreased by means of transformer. Large power plants operate on alternating current or AC. And let us now have a look at how a future power system could look like. Please notice the differences. First, you might observe that there are generation units located at the distribution system. They are not centralized as in the case of traditional power system, but distributed. This is known as distributed generation. Some examples are photovoltaic panels, small wind turbine system, or maybe biomass power plants, biogas power plants, or maybe fuel cells, etc. As you can see, the power flow not only goes from the generation system towards the distribution system, but now there are power flows going in the opposite direction as well. This occurs as a result of distributed generation, particularly in the case when more power is generated than consumed. You might have also noticed the presence of large consumers such as electric vehicles, and also the presence of intelligent nodes, or in other words, nodes in which smart grid concept will be enabled. You have probably heard the concept smart grid before. This term has been used for many applications. A smart grid is an electricity network that can intelligently integrate the actions of all users connected to it in order to efficiently deliver sustainable, economic, and secure electricity supplies. The users can be generators, consumers, and those that assume both roles. The word intelligently means that the power system employs monitoring, control, communication, and self-healing technologies to enable a power balance between generation and consumption. Let us summarize some of the main characteristics that power system will likely have in the coming future. First, a high percentage of power plants will be driven by uncontrollable sources, as opposed to the controlled centralized power plants that is mostly driven on fossil fuels. Secondly, considerable percentage of generation units will generate direct current or DC, as opposed to the larger power plants which generate alternating current or AC. Additionally, a considerable number of generation units will be based on renewable sources and will be of small scale located at the distribution system. There will be a bidirectional power flow. For example, when more power is generated at the distribution system than consumed. Storage will play a major role to deal the uncontrollable sources. Finally, smart grid concepts will be introduced to balance generation and consumption. In this lecture, we have discussed the main parts of a traditional power system, and we got an impression of how the power system of the future could look like. Thank you for your attention.